Hi, welcome to my video on the fundamentals of geometry, and this is practice 1 part B. Number 1, we have AB equals AC. We have a diagram that's here, as you can see, and we have this segment is parallel to this one, and we have this segment, which is 2 strokes, is parallel to this one, and we have says AB is equal to AC, two sides equal, and it says find the measures of angle 1, 2, 3, 4, and 5 in degrees. So angle 1, 2, 3, 4, 5 are here, and we got to find the degrees of these. So we have a 150 degree angle right here. This is a straight angle, 180. So that means that this angle right here is 30, because 30 and 150 makes a straight angle 180. Since these two sides are equal, that means that these two angles here are equal. Angle A, B, C, and angle C are both equal. So if they're equal, so there's 180 degrees in the triangle, so there it means these two angles must add up to 150. Or another way, this is the exterior angle of the triangle is equal to the sum of these two angles here. So these angles are 150, and because the sides are equal, the angles opposite sides are equal. So 150 divided by 2 gives me 75 degrees. So that means this one is 75 and this one is 75. And as a result of being 75 degrees, two lines intersecting, the vertically opposite angles are equal, so this angle is 75 degrees. And because this line is parallel to this one, this angle is 30, this angle 3 is also 30. And the reason being alternate interior angles, because this is the transversal and this is going across the transversal with the parallel lines. And we also have parallel lines right here, these two. So that means that this is 75, angle 1 is 75 degrees, because these are alternate interior angles. Parallel lines right here cut by a transversal, alternate interior angles are equal. And again, we have parallel lines here, which we had just in, so that makes this angle is 75 degrees, because these are alternate interior angles across this transversal. And if you add all these up, you have 180. So that means that's 105. So angle 4 is 75, because this is a straight angle, or because this line is parallel to this one. Angle 1 is 75, angle 4 is 75. They're equal because they're alternate interior angles. So I found all the angles. So angle 1 is 75. Angle 2 is 75. Angle 3 is 30. Angle 4 is 75. And angle 5 is 75. Okay, let's look at number 2. We have a triangle HTV, and it says that angle THV is 80. THV, this angle right here, is 80 degrees. So that angle is 80 degrees. I put it right there. And it says that HT is equal to HV. HT is equal to HV. Again, two sides of a triangle equal. Two angles are equal. So that means this angle V is equal to this angle T. Let's keep going. And it says that HW bisects angle THV. So HW, this segment here, bisects the angle THV. So that means this angle right here is equal to this one. So that means if that's 80, that means this one is 40. And this one is 40. And since that's 80, and these two angles here are equal in this big triangle, that's 180 in the triangle. That means these two must be adding up to 100. So that means 100 split in 2, because the angles are equal. These two angles are 50, 50. and we got a 40 and a 50. 40 and a 50, that's 90. So this angle here must be 90, and this angle X must be 90. So angle X must be 90 degrees, because the angles of a triangle add up to 180 degrees. Number 3, AB is 12, M is the midpoint of AB. So if, let's draw this, if AB is this segment is 12 units long, M is the midpoint, is in the middle, M is in the middle, which means that MA equals MB. So if this is 12 units long, and that's the midpoint, that means this must be 6, and this must be 6. So AM is 6 units long, because the midpoint is in the middle. And we have CD bisects HF at E, so bisects FH, so let's say that's the segment FH. And it says that CD bisects at E. To bisect must pass through the mid, so there's E. So if it bisects it, there it is there. So this is CD. If CD bisects FH, E must be the midpoint. So that means that EH must be equal to EF, because a bisector passes through the midpoint. Bisect means to cut in half, so that means E must be the midpoint of FH. Number 5, we have a triangle here. Let's see what the info says. We have AC is 12, so this is 12 units long right here. Okay, KB is 8. KB is 8 units long. KB is the perpendicular bisector. So KB is the perpendicular bisector. Perpendicular means we have a right angle right here at B. So angle KBA is a right angle. KBC, that's also a right angle. And the perpendicular bisector, not only perpendicular but it bisects. So that means the perpendicular bisector cuts AC in half. B is the midpoint. So that means that AB is equal to AC. That means they must be 6 and 6, because it bisects it, cuts it in half. And it says that BN is the median of KBC. BN is the median of KBC. A median is a segment drawn from vertex to the midpoint of the opposite side. So that N is the midpoint of KC. So that means that KN is equal to CN, because this is a median. BN is a median of this triangle KBC. N must be a midpoint. Now, how do we get the length? Well, what we have is that we have a right triangle. We got two sides equal. So C squared equals A squared plus B squared. Let's call this side KCB squared. A is 8, B is 6. So KC squared is 64 plus 36. So KC squared is 100. So that means that KC is the square root of 100. So it means KC is 10. So from there to there, we have 10 units. And since that's 10, and that's the midpoint, that means that must be 5 and 5. So NC is 5 units long. Again, using all the info that you can, median, perpendicular bisectors, etc., and the Pythagorean. A good question. Here we go at number 6. We have a triangle XYW. We have GT parallel to YW, and this is angle X is 70. So this is 70 degrees right here. And it says that XY, this segment, is equal to XW. Again, these two segments are equal. Big segments are equal. That makes that an isosceles triangle. That means the base angles are equal. So that's 70. Therefore, we have 180 minus 70 leaves us with 110. And 110 split in 2, divided by 2 is 55 here, and this one is 55. If two sides are equal, the angles opposite those sides are equal. So these two angles are 55. It says that YT is an altitude. YT is an altitude. YT is this segment here, is an altitude of XYW. XYW. So an altitude leaves a vertex and goes perpendicular to the opposite side. So that's a right angle right there. And that's a right angle there. So YTW and YTX are 90-degree angles. So that's a 90-degree angle. And it says find the values of A, B, C, and D. So we got a 55, 90. If this angle is 90, that means that this angle right here, TYW and W add up to 90, 180 altogether. So that means that that's 55. This one is 35. So C is 35 degrees. That means if C is 35, A must be 20. A is 20. Because it adds up to 55. And we have parallel lines. So if this angle here is 35, that means we got parallel lines. That means angle B is 35, alternate interior angles. So angle B is 35, alternate interior angles. This parallel line here, parallel line here. This is the transversal cutting the two parallel lines, so alternate interior angles are equal. So we have 20 and 35. We could go to 90. I want to get this angle here. Let's see, I could get this one and then this one. Let's go that way. I got a 90 and 35, so that means this is a 90, so this must be 35 and 90, so that must be 55 degrees. Which makes sense too. All this adds up to 180, 55, 35, and 90. And also that this line is parallel to this one, so these are alternate. These are corresponding angles on the same side, the transversal equal. So either add up 180 here, or the corresponding angles equal. 70 and 55 make up 125 degrees, and we need 55 more. Again, this is 55. Another reason, all these add up to 180, or these are corresponding angles. So this angle right here is equal to this one. Corresponding angles on the same side, the transversal, are equal. So angle D is 55. So just working your way around the diagrams using the properties. And the 180 in the triangle, corresponding angle is equal, alternate interior angle is equal, isosceles triangle, all these properties being reviewed. Number 7. How many diagonals can be drawn from only one vertex of a pentagon? Well, a pentagon is 1, 2, 3, 4. Pentagon has 5 sides. How many diagonals can be drawn from only one vertex? So let's take this vertex. How many diagonals can you draw from this vertex? So a diagonal, that's a side. So here's one diagonal. And there's another diagonal. Right here, that's a side, so it can't be. So the answer is 2. Only 2 diagonals can be drawn from one vertex. Number 8. How many sides does each have? A hexagon has how many sides? 6. A dectagon, I memorize it, has 10. Again, this have to memorize those facts. Number 9. The sum of the interior angles of an octagon. Well, the sum of the interior angles is defined by n minus 1 times 180. That gives us the sum of the interior angles of any polygon. An octagon has 8 sides. So we let n is equal to 8. So we go 8 minus 2 times 180. 6 times 180 gives us 0, 6 8 to 48 to carry 4, 1,000. So the interior angles of an octagon adds up to 1,080 degrees. Number 10, what's the measure of each interior angle of a regular nondegon? Well, let's look at it this way. N minus 2 times 180 is the sum of the interior angles of any polygon. But when it's regular, if you take the sum and divide it by n, then that gives you the size of each interior angle. And a nondegon is 9 sides, so n is equal to 9. So if I sub 9 in, right there, and I sub 9 in, again, the top is the sum of the angles, and dividing by 9 gives you the measure of each one. So if we want, we can go 9 minus 2 is 7. Divide by 9, we get 20. So we got 7 times 20, so we have 140 degrees. 140 degrees is the measure of each interior angle of a regular nondegon. Again, n minus 2 times 180 is the sum of the interior angles. When you divide by n, that's the measure of each one when it's regular. Number 11, find the exterior angles. The sum of the exterior angles of any polygon. The sum of the exterior angles of any polygon, no matter what polygon we have, is 360 degrees. All the exterior angles of any quadrilateral, any polygon. Quadrilateral, 4 sides. Pentagon, 5 sides. Triangle, 3 sides. Any polygon, quadrilateral, pentagon, hexagon, decagon, the exterior angles always adds up to 360. Find the size of each exterior angle of a regular triangle. Well, the size of each exterior angle. Well, all the angles of a triangle, exterior angles, add up to 360. So we take 360 and divide by n. That's the size of each regular angle. It's regular exterior angle. So the sum is 360. So the sum divided by n will give you the size of each one. So 360. A triangle has 3 sides. So each angle of a regular triangle is regular is, if a triangle is regular, let's look at it another way. If you have a triangle that has all sides equal, if all sides are equal, all angles are equal. So 180 divided by 3 gives each angle is 60 degrees. So if you extend that side out there, that's 180, so that's 120. If you extend this side out, this is the straight angle, so this is 120. If you extend this side out, this is 120. So if you've got a regular triangle, which is equilateral, you've got all the interior angles are 60 each, so the exterior angle is 120 each. This is another way to do it. Again, the sum divided by n gives you the size of each exterior angle if it's regular. What regular polygon has the interior angle equal to the exterior angle? Well, let's look at it as the interior angle. So the interior angle is n minus 2 times 180 divided by n is equal to the exterior angle. Again, it's regular. So the exterior angle is 360 divided by n. So this is the interior angle, this is the exterior angle, and they're equal. Notice they're over n, so that means that n minus 2 times 180 is equal to 360. And we multiply by 180, we will get 180n minus 360 equals 360. So that means that 180n equals 360 plus 360. We move this 360 over here, and that's 180n equals 720. So that's n is equal to 720 divided by 180. So n is equal to, and that goes into that 4. So what regular one is, that's 4 sides. So we could say quadrilateral. And another name for that could be, we could say, is also a square. So the regular polygon that has interior angles equal to the exterior angles is a square. And that makes sense because if you draw a square, 4 sides equal, and you have all right angles, so there's all right angles in this square, all sides equal, all angles are 90. If you extend the side out here, you got a 90 degree here, because 180. You extend this side out, you got a 90. If you extend this side out, you get a 90. And also right here, don't make a difference. I could extend it up here or here. I'll still get a 90. So the interior angle equal to the exterior angle. What regular polygon? It's a quadrilateral, particularly called square. Special. Number 14. The longest chord of a circle is the diameter. Diameter is the longest chord of a circle. If a circle has a radius of 6, then its diameter is blank. So the diameter is twice the radius, so it's twice 6, so that becomes 12. So it's 12 centimeters. Find the radius of the circle. The circumference is 9.4 feet. Circumference is 2 pi r, and the circumference is 9.42. And we change pi to 3.14, and that gives us 9.42 equals 6.28 r. So that means 9.42 divided by 6.28 is equal to r. So r comes out to be, if you work that out, take a calculator and divide that out, and you get 1.5. And so it's, the radius is 1.5 feet. 17. A polygon has opposite sides. If you draw, oh sorry, I said a polygon, a parallelogram. Parallelogram is this shape. So if you draw a parallelogram, the opposite sides are, number 1, parallel. Remind me, parallelogram. The opposite sides are parallel. Parallel lines. And the opposite sides are equal. So if you draw a parallelogram, you'll automatically have opposite sides parallel to each other, and you'll have opposite sides equal in a parallelogram. And number 18. It says that ABCD is a parallelogram. We have this angle here is 40 degrees. So this is a parallelogram. We have this side parallel to AD is parallel to BC. AB is parallel to DC. Opposite sides are parallel. So this is a 60. And that's a 40. Alternate interior angles are equal, so this is a 40. And we got a triangle here. ABC is a triangle. So this is the triangle here. We got 100 degrees adding up, 40 and 60. So there's 80 left, because 80 and 60 and 40 make up 180. And if this is 80, this line BC is parallel to AD. So that means this angle is 80 because alternate interior. So this angle here is equal to this one because of alternate interior angles. This angle here is equal to this one because of alternate interior angles. So that means that that's 120. So this is 60 because 60, 40, 180. 60, 40, and 80 make up 180 in the triangle. So angle D is 60 degrees. Number 19, a parallelogram with a right angle. So if we take a parallelogram, that's squished like this, and you give it a right angle, then you make it like this. So a parallelogram with opposite sides parallel and a right angle. So that's a parallelogram. Opposite sides parallel. Now if you make it a right angle, so if you make these parallel, and these are still parallel, but you make it a right angle in the corner, then you have a rectangle. So a parallelogram with a right angle is a rectangle. A quadrilateral with all sides equal, so I call it a rhombus. Some people call it rhombus, some people call it rhombi. Rhombus is the plural. Rhombus, all sides equal. And a rhombus is like a square. If you take a square and push it out of shape. So you have all sides equal length. There's all sides are equal. And we don't have a right angle. We don't know. We know that it has all sides equal, but they're not, the angles are not right angles. Find the length of a diagonal of a rectangle whose sides are 5 and 1200 centimeters. We got 5 meters and centimeters, so we got to convert. So 5 meters, so 1 meter is 100 centimeters. So we divide by 100 and we will get 12 meters. We got to have the same units. So 1200 centimeters is 12 meters. And we got to find the length, so of a rectangle. So this is a rectangle. All right, rectangle got all right angles. So if you draw a diagonal and it has sides of 5 and 12, and because it's a right angle, we'll use Pythagorean. So c squared is equal to a squared plus b squared. We call this x. So x squared, x is the hypotenuse. 5 and 12 are the two legs. So x squared is 25 minus 144. X squared is 169. X is the square root of 169. Square root of 169 is 13. So the length of the diagonal is 13. 13 and is in units, so we're going to say meters. I could have worked it out in centimeters, but the numbers would have been way larger. Number 22. Complete each about a square. If you take a parallelogram, which is this, there's the parallelogram. We draw a parallelogram, normally I draw it like this. So if you take that parallelogram and you want to make it a square, so you have to have the adjacent sides equal. So you have to have these two sides equal. Opposite sides are equal in a parallelogram. So if you make the adjacent sides equal and you put a right angle in it, got to have a right angle. You got to have a right angle to get a parallelogram to be a square. But the adjacent sides are equal. That means all sides are equal. And a rectangle. So if a rectangle looks like this, there's a rectangle like this. And notice that this side is equal to this side, and this side is equal to this side. So it automatically has a right angle. Rectangle got a right angle. So it has to have adjacent sides equal. So if you make this side equal to this side, then all the sides will be equal. So a rectangle with adjacent sides equal is a square. And a rhombus, this is a rhombus. A rhombus has all sides equal. So if all these sides are equal, so it's not the sides we need to make it a right angle. So if you take a rhombus and give it a right angle, like you make it like this. So if you take that rhombus and take the rhombus and push it back here, it'll make a right angle. So all the sides are equal. There, all the sides are equal. But you have to have a right angle in a rhombus to get a square. It's just a review of the quadrilaterals properties. So that brings us to the end of the review on the fundamentals of geometry. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. Content on my YouTube channel called Math Fully Explained. One word. Thank you for viewing my video. Hope the video helped you. Bye-bye.